So in this question, as you see this ramp on which a block is placed and a force F is exerted on this block, but just for a moment, just assume there's a no force exerted on this block, this F I'm talking about. So then in that case, there will be the two forces. The one is a force of gravity and the other one must be the normal force, and that normal force will be countering the one component of weight. This is mg cos theta. So this normal force will be balancing this one, and the other component is mg sine theta. I'm talking about that assumption in which we have ignored the involvement of this force in this scenario, in this circumstance. So you see that mg sine theta in this scenario is the only force which will accelerate this block, which will push the block down on the ramp, okay, which can slide the block down to the ramp. So that's why now we are applying a force F that is used to hold the block of mass m on the incline. And in this question we have to calculate the expression of this force. So let's start with the free body diagram. So students, this is our coordinate system in which we are assuming that the up on the incline must be positive. It's our assumption. And here this is our y-axis. So the up on the, like, this is a positive and down is a negative. Okay, now how many forces? We are applying an external force to hold this. So this is a force F that I will also show you in our free body diagram. So now be careful while drawing the free body diagram. We should also be careful about the length of the vectors that we will show here. Now there's another already a force that we are applying in the negative y direction. I'm talking about this force F. Okay, so that's why. And what should be the direction of the frictional force? That must be the direction of frictional force. So let's say this is a frictional force, and this should be the direction of weight. Okay, so weight Fg. Now I will draw the maximum length of the normal force. Why? Because this is a normal force actually which is countering the two forces in opposite direction. uh, I hope you understand. I'm talking about that this normal force is balancing the two forces. The one is this applied force, and the other one is the component of this weight. Okay, so this is angle theta. So, students, if we draw the components of the weight, so that I'm talking about this one. This is our y component, and this is our x component of the weight. So that's why I'm going to show it here that this is mg cos of theta and this one is a mg sine of theta. So mg sine of theta is only countered by the frictional force. All right, there's no other force that is countering this one. And we will also write it, because this is our equation, that the frictional force is equals to mg sine theta. So this is all the forces on x-axis, but what about the forces on the y-axis? So you know that this is our applied force, so that is a force F, and this was the normal force Fn. So let's make equation, because the system, the object is in equilibrium. That's why we can say that the normal force must be equals to mg cos of theta plus this applied force. So this is a coefficient, like this is a static friction, so that's why it must be mu, and the normal force, this mu is a coefficient of static friction. Mu times normal force is equals to mg sine theta. Now if you see all the options, we don't see any normal force factor in all of the options. It means we must eliminate this normal force. So normal force must be equals to mg sine theta over coefficient, and now we can plug this value here, and in that case we can find out the applied force. So it must be mg sine theta over coefficient is equals to mg cos theta plus applied force. You can take this factor on the other side because we want to find out the applied force. So then it will become mg sine theta cos theta is equals to f. Now dear students, you can see we have a one common factor from this, and that is mg. So you can take it out of the bracket. So inside we have sine theta over mu minus cos theta. Upon further solving this expression, it will become mg into sine theta minus coefficient times cos theta divided by coefficient. So this is finally the force that actually we needed to know. So this is a minimum force, and that's why our right answer should be option D.